Hello dear students, welcome to Tejama YouTube channel. In this video I am going to discuss about a small concept, that is continuous charge distribution in the chapter electrostatics, or you can consider specifically it is electric charges and fields. So why is the continuous charge distribution required? See, till now whatever we have learned, like in coulombs force and electric field, we have considered discrete charges or one or two charges distributed in regular manner. So in practical, actually there will be huge number of electrons. If you consider this pen, in this some trillions of electrons and protons, neutrons will be there. So one or two charge distribution is theoretically considered, but practically it is not possible. Okay, there will be huge number of electrons are present around us, in us. My body is made up of atoms, right? Your body is made up of atoms. This, what is the book, is made up of atoms. This pen is made up of atoms. Your body is made up of atoms. Atoms are talking with atoms. Okay, in that atoms we have electrons, protons, neutrons, and then there will be distribution of energy. What is that? Transfer of energy. All these things occurs. Now in this video I am going to discuss about the three types of charge distribution. That is, one is linear charge distribution. If the charge is present or distributed along a wire, that is called linear charge distribution. If the charge is distributed on an area, that is called area charge distribution. And if its charge is distributed in the volume, okay, distributed all over the volume, that is called volume charge distribution. And we define terms like linear charge density, surface charge density, and volume charge density. And I will also tell you how to use them to calculate electric field and electric force. Okay, we will go one by one. First one, it is linear charge density or linear charge distribution. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? Distribution. Here let me consider a wire in which large number of charges are present, plus 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 plus, some crores together charges are present. What I will do is I will define a term called linear charge density. Linear charge density represented by lambda. Okay, so lambda is given by, so in board examination they will ask you to define linear charge density. Linear charge density is defined as charge per, okay, charge per unit length. You can take the total charge divided by length, or you can take a small charge element in it which is having a charge dq and whose length is dl. Therefore lambda is given by dq by dl. Now this lambda is given by dq by dl can also be written as dq is equal to lambda dl. Using this we can find out the total charge. How? Just do integration. If you integrate, you will get lambda into dl. This is the total charge present all over the what is this wire, which is uniformly distributed. Now sir, how to find out electric field? Electric field find out ಮಾಡೋದು ಹೇಗೆ? So at any point, random point, I need to find out electric field. Okay, let's consider here I need to find out which is at a distance r. So electric field due to this one, if I consider electric field due to this complete wire, if I consider, that is given by 1 over 4 pi epsilon naught total charge divided by r square, right? So here you can substitute 1 over 4 pi epsilon naught r square. What is q? Lambda into dl. And if I place a charge, test charge, that is q naught, the force experienced by it is given by q naught into E. Alva, this is the coulomb force that we have studied in terms of electric field. So E value will substitute ಮಾಡಿ. So 1 over 4 pi epsilon naught into r, q naught is there, q naught into lambda dl. ಈ ಟರ್ಮ್ಗೆ q naught ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಅಷ್ಟೇ. you will get force. So what is the unit, sir? Linear charge density unit is coulomb per meter. For charge it is coulomb, length it is meter, coulomb per meter. Don't get confused. Sometimes if I give the question in the exam, students write instead of considering it as coulomb per meter, they consider per centimeter. Okay, don't get confused. So this is about linear charge distribution, and lambda is the linear charge density. Now let us discuss about surface charge density and surface charge distribution. So, sir, what is surface charge distribution? Surface charge distribution. Surface charge distribution. So surface charge distribution, here if I consider, let me consider, this is surface on which charge is distributed uniformly. Alva? Charge is distributed uniformly. Charge is distributed uniformly. So now if I consider a small area in it of area dA, charge is given by dq. So here I define a term called surface charge density. Surface charge density represented by sigma. So sigma is given by dq by dA, and its unit is coulomb per meter square. Coulomb per meter square. Alva? Now this can be written as dq is equal to sigma into dA, and its integral form is given by integration sigma into dA. Next, electric field can be defined as 1 over 4 pi epsilon naught q divided by r square. At any one particular point, electric field is how much? Point P, this much. So 1 over 4 pi epsilon naught. Q value is sigma into dA divided by r square. I will write here. Okay. And then what about force? Let's consider here there is a test charge placed at Q naught, and force is given by Q naught into E, that is equal to Q naught divided by 4 pi epsilon naught into r square sigma into dA. This is about surface charge distribution. So surface charge distribution can occur on the sphere, conducting sphere also. Conducting sphere. Okay. So on the conducting sphere, there will be charge distributed uniformly like this. Conducting sphere. If we give charge to a conductor, the charges will go and accumulate on the surface. What if it is a non-conducting sphere? We have to consider volume charge distribution. Okay. So let us consider that. Next, hope it is clear to you all. Sir, how to define it, sir? Simple. Yeah. Surface charge distribution is defined as charge per unit area. That I have not written, charge per unit area. Okay. Then we have last one, that is volume charge distribution. Volume charge distribution. So in which we have, what is this? A three-dimensional object. Okay, this is a sphere, not the circle. This is a sphere. So here the charge is distributed all over its volume. So what is the charge distribution in the given volume? What is the charge distribution in the given volume? Okay, that is defined by surface charge density. Okay, surface charge density, sorry, this is volume charge density. Volume charge density rho is defined by charge per unit volume, that is, in this case I will consider a small volume, so rho is equal to dq by dv, that can be written as dq is equal to rho dv, that can be written as q is equal to integration rho dv, integral form. Sir, what is the electric field at a point due to this one, sir? Can be defined by 1 over 4 pi epsilon naught q divided by r square, where q is rho dv. Okay, and electric force due to the small charge element dq and dv at this particular point placed q naught is q naught into E. Okay, q naught into E, that is equal to 1 over 4 pi epsilon naught, this is q naught, into sigma rho dv divided by r square, and its unit is charge per unit volume, right? Coulomb per meter cube, this is the unit. So these are the three different distributions, that is linear charge distribution, surface charge distribution, and volume charge distribution are very important. So based on this we are going to derive the Gauss law applications. So after that I will be discussing about dipole and what is the electric field along the equatorial, along the axis, and at random point. So all these things we will be discussing in the coming videos. Dear students, if you feel these videos are useful, please share it to your friends, suggest them, so I can get motivated and make more videos like this. And I have plans to explain the NCR textbook line by line also, as some of the students asked. So I'll be doing that, but only by your support. Thank you so much.